discuss about one of the critical problem related to the ground load and ground pressure and the condition of ground load and ground pressure, particularly a critical condition of ground encountered during tunneling known as squeezing ground condition. In this, we are going to elaborate about the rock load and ground pressure in brief, then application of the rock load or ground pressure in general. So here we are going to elaborate this and then going to apply this concept in prediction of squeezing ground condition. So first, what is a rock load? What is the concept of ground? We have already discussed in our class discussion regarding concept. Here I try to elaborate one by one. Here, if we are going to see any ground initially with equilibrium state of in situ stress, in situ state for in situ stress. So what is the in situ state of in situ stress? That is equilibrium in condition, and this strata is intact, able to bear all kinds of load in present position. When we are going to excavate an opening, then there is disturbance in situ stress. Due to disturbance, there is change in pattern of in situ stress, change in pattern of in situ stress, and such disturbed condition of in situ stress try to reach its equilibrium again to make the whole system stabilize in nature. Therefore, there is a redistribution of in situ stress, redistribution of in situ stress, and if this strata is able to bear the redistribution of in situ stress, then no problem. If this strata is unable to bear the redistribution process of in situ stress to reach the equilibrium, then there is a deformation. The similar effect we can also see in living component. If a body is unable to bear the impact of any load, any punch, or any thrust, then there is some deformation in form of fracture, in form of cracks, in form of deterioration, damage of the nerves and others. Similarly here, if the strata is unable to bear the redistribution process of in situ stress, which is induced due to creation of this opening, then there is a development of deformed zone. And this deformed zone is known as broken zone or deformed zone or damage zone. Through any name we can recall, and this is a practically detached from the original strata. This type of rock mass, mechanically induced or stress induced rock mass, which is due to creation of this opening, starts moving towards the center and ultimately resulting the collapse of all created opening, loss of money, loss of time, and sometimes maybe injury or some fatality, damage to instruments and others. So the load due to movement of such damage zone is recognized as rock load. Rock load is nothing. Rock load is the weight of detached or dead rock mass which is detached from the original ground, and this detached rock mass from the original ground is leading to damage, failure of support system, means lining and others, and ultimately resulting collapse of this opening. This all fall under this and finally going to close this opening. So therefore it is important to know the rock load, and if suppose for example here some support system in form of steel, if we are going to put here a load of 5 kg or 10 kg, hypothetically 10 kg, then there is this load is going to make some impact on this support system. So the pressure experienced at the support is a ground pressure. Means pressure experienced by the ground are subjected under load known as ground pressure. Ground pressure. This ground pressure is nothing, it is other word rock load. So rock load or ground pressure is almost same, and the problem is here, if this opening we are going to create in rock, no problem. In view of the strength, modulus of elasticity, Poisson's ratio, stress, deformation, behavior, and others, we are able to calculate the load and ability of the ground, etc. If the ground is made up of here rock block and this discontinuity, here rock block is here, we can know the strength, modulus, and Poisson's ratio and behavior with respect to external changes due to redistribution of stresses. However, the traverse of this such type of discontinuities is a major problem. And still we are unable to clearly say that this part of rock is going to show a particular strength, because this interface is creating major problem. Another aspect regarding the thickness, because the mass, total volume of the material, or in another word mass into unit weight of the material, here such volume depends on the characteristic engineering geological characteristic, or in another word the technical geotechnical characteristic of rock strata. And rock strata, as you know, it is not made up of rock only, it is made up of these interfaces also. So therefore the quality quality of rock mass, which is integral part of this rock strata, is participating in formation of such type of damage zone. Theoretically, if the rock mass is poor in category, then there is a formation of a damage zone having very high thickness or the more thickness, and finally we are unable to tackle such type of problem, and ultimately this created opening may fail. If the rock quality is a good quality, then there is a formation of very limited damage zone, which can be tackled by installation of steel arches or in concrete spraying or grout spraying or slurry spraying or rock boltings and others. So we can say that the thickness of broken zone is a function of rock mass quality. This rock mass quality in general means, or in another word we can say that the function of engineering, geological or geotechnical, engineering, geological characteristic of rock mass. Means indirectly we can say that if the strength of rock mass is a more, then there is a less thickness of the broken zone. If strength is a weak, means rock mass is a weak in nature, there is a formation of broken zone of higher thickness. Means large volume of damaged rock or detached rock going to create heavy load, and if the ground is strong enough, then there is no rock load is going to create massive damages to the ground. For example, if the interfaces are traversing the ground where we are going to create underground opening, means creation of tunnels, caverns, underground, military chamber, repository, etc. Then in such situation, because this whole thing is intact in nature, there is no discontinuity. Discontinuity is beyond this opening. It means it is close to rock. And in such situation, when these discontinuities are traversing outside the created opening, means we are having the intact block in which we are going to create opening of suppose 8-meter diameter or 6-meter diameter and 1 kilometer length and others, then there is zero thickness of damage zone. Means the strata is a competent, hard, compact and strong, able to bear the redistribution induced load redistribution of in situ induced load, which is responsible for creation of such type of damage zone. So in strong compact rock, there is no damage zone, and the created opening, created tunnel is self-supporting. There is no requirement of any support system. So here in intact rock, we have no any problem, but in case of this rock mass traversed by varieties of discontinuity, means having different geotechnical characteristic or engineering geological characteristic of the joint and the nature of rocks. For this, we have one concept regarding rock mass classification. Rock mass classification is nothing. It is an approach to change the description of rock strata from qualitative to quantitative. It is attempt, and still we are trying to translate the information related to ground or related to geological formation in form of some numerical values, so that engineers or planners or other persons can utilize value for calculation of load, for proper design and planning of the engineering structure, construction of engineering structures like tunnels, like caverns, like underground spaces, etc. Rock mass classification is an empirical approach to anyhow quantify the ground in terms of some values. Initially, Tarjagi in 1946 has categorized total ground in 9 categories and written in terms of Roman letter first to 9, like intact rock, like stratified rock, like moderately jointed and semi-rock, like very blocky and semi-rock, like moderately jointed, like squeezing at moderate depth, like squeezing at great depth, like crushed rock but chemically intact, etc. And this classification given by Tarjagi, as you know, modified later by Deere et al. In 1970. And Deere et al. Has added the concept of rock mass, rock quality designation, rock mass quality designation or rock quality designation. This rock quality designation is a very simple thing, RQD, based on the core of annexite. Annexite is a 54 mm in diameter, and the summation of all cores more than 10 cm. We are excluding here equal to 10 cm. Always considering more than 10 cm. Why? Because we don't want to take any risk. If we are considering the up to 10, it means the value may be slightly less. If we are considering the 10 cm more than, then we are safe side. So all the cores more than 10 cm divided by total length of drilled hole or drill run. In this way, we are going to calculate the RKD by in percentage, means by multiplying 100. Suppose, for example, suppose in a coring operation, the core drillers have obtained the cores of 12 centimeter, cores of 32 centimeter, core of 6 centimeter, core of 9 centimeter, core of 17 centimeter, etc. in drill run of suppose 1 meter. So here we are going to consider the cores which are more than 10 cm, means excluding this 6 cm, 9 cm, and in this way we are going to add here 12 plus 17 plus 32 divided by this 1 meter, means 100 cm, and multiplied by 100 cm. So you can get this value here 3, 7, 9, 11, and then 31415. So in this way you are getting RQD. This RQD is a single parametric classification able to categorize the rock mass in categories like very poor, poor, fair, good, and excellent. We started from this 25, here 26 to 50, 51 to 75, like this. So in this way we can able to declare a particular ground is belonging to very good, or belonging to excellent, or belonging to good, or belonging to poor or fair, etc. So in this way we are going to categorize. If a ground is of having good quality, no problem, there is a development of minimum rock load and others. Similarly, we have other attempts also based on multi-parametric. Here two attempts, one by Beniavsky in 1969, 67, 69, 30, 30, 70, 73, etc. The Beniavsky have suggested rock mass rating system, and in view of the rock mass rating system, that is an attempt to include various geotechnical parameters of ground like uniaxial compressive strength of the rock, like rock quality designation RQD, like joint spacing, like joint condition, like groundwater condition, like joint orientation, etc. So in view, he has simply sum all the parameters in form of rating, parameter 1, parameter 2, parameter 3, all which we have already described. And in this way, we are getting the RMR value. And in view of the range of RMR value, again, we are going to categorize very poor, poor, good, very good, excellent, and others. So up to very good, the Beniavsky have suggested. Similarly, the another index that is known as rock mass quality index, given by Barton et al., Nick Barton et al. From Norwegian Geotechnical Institute, 1974. They have suggested a rock mass quality index Q, and Q is also having 6 parameters arranged in 3 quotients. First quotient is RQD divided by joint number into joint roughness divided by joint alteration into joint water condition divided by stress reduction factor. This quotient, three quotients representing the three aspects. First quotient represent about the block size by which a ground is made up of, or a geological formation comprised of a particular size of block. It may be fragment size, it may be sand size, it may be boulder size, it may be cobble size, it may be very big blocks, etc. So in this way, we are able to see a ground is made up of which type of component. It is made up of big blocks, or it is made up of teeny type of components and others. So in this way, this first quotient is able to analyze the nature of ground. Second quotient is representing here inter-block shear strength. So here nature of ground can be evaluated through this parameter, as well as here the strength of ground through this second. And third, about the condition. The ground is located in waterous region under high in situ stress or tectonic stress or dry condition or partially saturated condition, etc. So about the surrounding, about the strength, and about the nature. So in this way, this Q system is able to suggest the quality of ground, and the value of the Q system ranges from 0.001 to here 1000. Among this, we are going to categorize the different means here 10 to power minus 3 to 10 to power 3. The value of this Q presented in semi-logarithmic way starts from the quality exceptionally poor at one stream and another side exceptionally good. Then extremely poor, then here extremely good, then very poor, very good, then poor, then fair, then good. So in this way, you can see our discussion class. Here we have already elaborated which level of value is representing very extremely poor, exceptionally poor, very poor, poor, etc. So on the basis of this, we are able to categorize. Now, as far as the rock load is concerned, we have different approaches. Before discussing different approaches, here we have to analyze certain things easy for evaluation of in situ stress. Here, first thing about the state of in situ stress. State of in situ stress means already stress remnant in ground. Suppose this is the ground. Here, what is the condition of this in situ stress? It is a high, it is a moderate type, low type, or very low, etc. These form due to overlying strata here. So due to overlying strata and tectonic stresses and others, the stress can be resolved as vertical as a horizontal maximum minimum, sigma h min, sigma h1 max, and sigma v. So in this way we are going to see. Second, about the strength, compressive strength or simply strength of rock. Then about the strength or mechanical properties of rock elements, and as well as mechanical properties of rock mass. Then about the spatial distribution of discontinuities, and then about the strength of discontinuity. Strength of discontinuity or mechanical response of discontinuities. Here, these parameters we are going to see to know about the condition, about the strength or mechanical response of rock as well as rock mass, as well as the discontinuities present in rock mass. So in true sense, we can say that none of the ground is made up of rock. All kinds of ground is made up of rock strata, which are integration of the rock mass. We can say that in case of intact rock, the rock mass is equal to rock plus joint or discontinuity. If the joint is a zero, it means it is a rock mass is rock. Otherwise, if any discontinuity is present, then this ground is made up of rock mass, not rock. So rock mass is a safe terminology which we can utilize safely. Regarding the method for estimation of rock load or ground pressure. The rock load or ground pressure, why we require, sometimes come in our mind, why we require ground pressure or rock load unnecessary. Actually, the ground pressure is an estimation or rock load is an estimation of load which are coming on the support system installed in created underground space structure like caverns, like underground museum, like underground military chamber, or any type of underground structure. Friends, as you know, the creation of underground structure is more complicated in comparison to the structures we are going to construct on surface. So when we are going to utilize this geological formation as a base for construction of dam, for construction of building, for construction of the bridge foundation and others, then there is a minimum problem regarding the distribution of load or stress. However, when we are going to create any structure considering the geoground or geological formation as a host, then there is a lot of problem because we are going to play with in situ stress. Already existed stress present in rock body. Then in such situation, very difficult to calculate the load because and load is a input for proper design, proper implementation and installation of support system. Here we are going to define about the method. First method, very important, is empirical method. Second, partial empirical means semi-empirical method. Third, about the structural defect method. Fourth, about the rock support interaction method. And fifth, about integration of all these above method under the unified method, means integrated method. As far as this empirical method is concerned, we are utilizing the rock mass classification, which is also known as geomechanical rock mass classification or geotechnical rock mass classification or engineering geological rock mass classification. The empirical method is utilized ultimately to assess the response of ground, and as we have already discussed, the formation of detached zone, broken zone, which is responsible for rock load, is based on the response of ground. In this way, in this indirect way, we are going to estimate empirical. Empirically, the rock load or ground pressure which are necessary for designing to stabilize, for designing support system to stabilize a particular excavated or bored underground space structure. Semi-empirical, partially we are utilizing empirical and partially analytical approach. This is oldest method. And regarding the empirical method, we have already discussed. First attempt was made by Tarjhangi in 1946. Actually, a job was assigned to Tarjhangi to develop one tunnel for crossing of some railway track in Alps. At that time, there was no concept of the rock mass classification. So anyhow, Tarjhangi has categorized the total rock strata encountered in Alps in 9 categories based on his table work in level. Later on, that concept was utilized for the estimation of rock load in terms of rock load pressure factor. In such condition, a rock load factor, such factor is easy and very useful for estimation of underground structure of a particular width, of a particular height, and utilized through the drilling and blasting. At that time, drilling blasting was famous for fast rate excavation. Still, we are utilizing the drilling and blasting technique, which are labor friendly and easy, cheap also. Structural defect method is a very peculiar method responsible for giving the concept of block. Therefore, it is also known as block theory. Here, very simple. Any structure is formed a block when two discontinuities is going to intersect along with the surface of this created opening, then this block is detached. For this portion should be rigid in nature. These interfaces are weak in term of tensile strength. Due to weight and gravitational effect, this block is going to move toward this. Then taking this place, this block is going to cover this area. This block is going to cover this area. This block is going to cover this area. And finally, this block is here present. This cartoon is representing here. Then another block is located here. And finally going to collapse this whole opening. This concept was given by Goodman in 1985 and later are modified by many, presently Duker and Fraser and others. Nowadays, the number of software based on the finite element concept and finite difference concept and others, creating such type of nodes and seeing the deformation of this ground in term of certain this tetragonal type of blocks. So I have given some base for computer based development of numerical method based softwares. Here, rock support interaction is a back analysis approach. Here we are going to see the impact of the rock load on support system and analysis of condition and features formed due to impact of rock load on support system. We are going to assess the value of rock load. For example, here, this suppose very simple thing. One support here is steel block we are utilizing and simply you are going to put here 1 quintal of load or any load having more weight. Due to this, what happens? This support system may be getting this type of shape and maybe some distortions in features and others. After carefully analyzing the changes inherited this support system and come in form of this, we can say that the support system was subjected to a particular 1 quintal load. So based on the condition, based on the impact, we can predict a particular support system is subjected to this amount of rock load, and after creation of a particular opening, the rock load was this much. Means this is actually experience-based approach, analysis of the impact, and in backward side we are going to infer the actual rock load based on the analysis of this damage. Another approach is unified, considering all the aspects to avoid any kinds of risk in this calculation. So finally, we can say that the support system and others we are getting through this type of approach, and this is useful for calculation of rock load. We have already concept of the a chart presented by Tarjagi in 1946, modified by the Deer et al. In 1970, adding some RQD value utilized for determination of rock load in a smooth way. In addition to this, the RMR system is also utilized, and the Q system is also utilized for calculation of the rock load. Rock load encountered during the creation of underground opening and others. So here one example here I try to give, and another aspects we will discuss in our next attempt. So here, for example, Q. If we are going to calculate the support pressure, here we are simply going to make this relation 0.2 divided by joint roughness multiplied by Q power minus 1 by 3. Suppose the quality of the rock is, suppose Q value is 8, joint roughness is supposed to assume 2, then you are able to calculate the vertical ultimate pressure. Here 0.2 divided by 2 into 8 power minus 1 by 3, it means it become 1 by 2. So 0.2 divided by 2 into 1 by 2. So in this way, you are able to see here 2 by 4 into 10. So in this way, you are going to get the value of load. Similarly, RMR also we are going to utilize in different way. Here we are going to see the 100 minus RMR divided by 100 multiplied by unit weight of the rock multiplied by the span of opening. However, in this relation, there is some problem related to the unit. So therefore, we are generally apply 1 meter into 1 meter, because for unit area, we are going to calculate. Here, for example, suppose the RMR was 70 for any rock mass, and the unit weight of, suppose, consider 25 kilonewton per m3, and width is suppose 10 meter, then you are able to calculate 100 minus 70 divided by 100 into 25 kilonewton per m3 into this 10 meter. So here square m square is getting here after cutting off this m. Therefore, it is suitable to multiply 1 meter by 1 meter to neutralize this and getting this value in term of kilonewton. So in this way, we are going to see another calculation about the rock load. We will discuss in our next class. In the meantime, you have to prepare for your questions to ask in next class, or you can contact me on email dubey@iitism.ac.in for any kinds of query. Next session, we will discuss this aspect along with other aspect in very brief, so that I can give some overall view and you can understand properly. Best of luck. Thank you very much.